Lesson number 6 is more of a review than anything else, but let's start by looking at class example 1. Keeping in mind that we've covered all these different types of methods of determining whether something is a permutation or a combination. So the first thing we looked at was the fundamental counting principle, then we looked at factorial notation, and then number of permutations in the form of R or N, and then we looked at permutations with their repetitions, and then combinations. So first of all, if we consider the word poppies, there's 1, 2, 3, 4, 5, 6, 7 letters. And how many arrangements can be made of the word poppies without any restrictions? Well, there's 7 letters, but there's 3 different P's. And so 7 factorial divided by 3 factorial. You get 840. Now, if the arrangement begins with a P, so we know that the first letter has to be a P, and then all the other letters can be, there's only 6 letters remaining. So 1, 2, 3, 4, 5, 6. So it could spell the word, well, it's spelling the word poppies. Now, remember that there are still 2 P's left, and so we still have to divide it by 2 factorial. So 6 factorial divided by 2 times 1, we get 360. Now the first 2 letters have to be P, so just like we did last time, P is going to be my first 2 letters, and then I have 5 that are left after that. So this could be P-O-P-I-E-S, for example, which would be 5 factorial. Because these two don't really matter. It doesn't matter which P goes first. There's just these 5 letters to choose from. 5 times 4 times 3 times 2 times 1 is 120. Now all the P's have to be together. Now it doesn't matter which P goes first or not, so we don't have to divide it by 3 factorial this time, just like the last time. But we do know that all the P's have to be together, so they essentially count as one letter. And so we're left with O, I, E, and S, which should just be 5 factorial again, or 120. Now the first letter is a P and the next one is not a P. So P is the first letter, and after the first letter I have 4 options, right? I have O, I, E, or S, which the letters can possibly be. But after that, I can have my letters P in there and the other 3. So what this becomes is I have to keep this in mind, so that will be 4 times 1, 2, 3, 4, 5 factorial. 5 factorial is 120. And since I still have 2 P's, or 2 P's that can go anywhere here, I have to divide that by 2 factorial. So 5 factorial is 120 divided by 2 times 4, we get 240. Alright, let's look at the next example. Class example number 2. So a class consists of 5 girls and 7 boys. A committee is then to be formed consisting of 2 girls and 3 boys. And we want to determine the number of ways the teacher can choose the committee if there are no further restrictions. So this is it. It only has to be made up of 5 girls and 7, or 2 girls and 3 boys, and we have 5 girls and 7 boys to choose from. So let's first look at the girls. That would be 5, and out of the 5 girls, we have to choose 2. And out of the 7 boys, we have to choose 3. And this would be 5C10 or 5C2, that equals 10. And C3 equals 35. So 350 different ways without any restrictions that we can form a committee with 2 girls and 3 boys if we have 5 girls and 7 boys to choose from. Now, here's a restriction. Johnny, the principal's son, has to be on the committee. So we still have the 5 girls to choose from, but since one of the boys is basically already chosen, there's only 6 left to choose from. And so we know that this is equal to 10. 6C2. It's 15. And so if we already have one of the boys chosen, then there's only 150 other ways to make this combination. Now the twins Peter and Paul cannot both be on the committee, and so if they can't both be on the committee, then there's 3 different. So Peter and Paul, not both of them can be on the committee, so it can either be Peter, Paul, or neither. All right, and so they can't both be on the committee, and Johnny, the principal's son, has to be on the committee. So let's start with the girls. The girls is always going to be 5C2. And since the principal's son still has to be on the committee, then, and Paul or Peter can or can't be on there, so that only leaves 5 boys to choose from, and then only leaves 2 spaces. And same with this example here. If it's Paul, like it was Peter, it's still going to be 5C2 with the girls, and then Paul, which would be 5C2, because we're also considering we're still considering the principal's son in this example. Or if there's neither, so 5C2, and if neither of them can join, then we have 5C, but now we have 3 boys to choose from. And if you add these all up, that's going to be 10 times 10 plus 10 times 10 plus 10 times 5C3, which is 10. And so this gives us 300 different ways. Now the next question, David, Stephen, and Helen were trying to answer the following homework question. So the students in a school band have practiced 5 popular, 6 classical music compositions. For the school concert, they will choose a program consisting of 3 popular and 2 classical music compositions. If the order of the compositions matters, determine the number of different programs which can be presented. And this is how they answer. So if possible, discuss the merits of each answer with other students and indicate errors in any of David, Stephen's, or Helen's reasoning. All right, so this is a question that I want you guys to discuss, and then we will go over it later in class.